All right, so now we're ready for the really fun part. We get to do abbreviated truth tables. Abbreviated truth tables are much more tricky, much more fun. You must know your truth conditions very well in order to do abbreviated truth tables. So let me start with the warnings and some overall advice. Please know that if abbreviated truth tables freak you out, you just can't wrap your head around them, you are not the kind of nerd that doesn't get invited to parties, you're a cool kid, don't worry, life is fun for you right now, you're getting all the dates and all the attention, right? So don't worry. But nerds, remember, we'll have better lives in the future. So you cool kids, try to become nerds very quickly. By the time you get into your 20s, there's no advantage to being cool. You want to be a nerd. Okay, back. So, if you are freaked out by abbreviated truth tables, please note you can always do a full truth table instead. So when I give you exam questions about truth tables, you can use either method. But I do say this though. Sometimes an abbreviated truth table can get tricky, right? And so do know that you always want to have the skill of a full truth table in case you get stuck. So if you're working an abbreviated truth table, you don't see any of the shortcuts, right? It's getting confusing. Just go back and do the full truth table. So make sure you have that skill. And again, if you aren't confident with abbreviated, you can always do full instead. All right. So now, an abbreviated truth table has the exact same goal as a full truth table, right? So again, look at my little screen. We are working with this definition of invalid. This is what our goal is every time. Remember, we are negative, cynical, pessimistic. We are terrible people. We want to defeat all arguments. How do you defeat an argument? By proving it's invalid. How do you prove it's invalid? By showing that it's possible to have all true premises with a false conclusion. In our table, obviously this means we are trying to find at least one row that has all the premises true with the false conclusion. Now, in a full truth table, you fill in all the possibilities and look for an invalid case and see how you've done. But nerds are saying, Jeff, why am I looking at all these extra possibilities when I'm only looking for this case? Why not force this case? Why not simply try to find that line instead of looking at all of them? Exactly the point. But again, this requires you to know your conditions for each connective backwards and forwards in order to see these sorts of shortcuts so you can try to do this. So here's our strategy. Good. Actually, let me put those all together on the same page. This would be a good thing to screen grab, right? Or to take a photo of. This would be good notes to have for abbreviated truth tables. So here's our basic strategy. Now this isn't step by step all the way down, right? Because a lot of work is in your head. So we start the same way, write your argument out in a single line, label the main connectives. Don't forget your goal. Now, 4 through 6 are really tips or rules. They're not necessarily steps, right? Because I'll show you the steps are kind of up in the air. The most important restriction here is this rule 4, strategy 4. You must assign values to sentences consistently. What does this mean? You can assign whatever value you want to any sentence letter, but you can only assign consistent values in a row. Think of the different rows of our truth tables as different worlds that could occur, different possibilities, different situations you could find. Well, notice, you still have to obey the law of non-contradiction. If a sentence is true, it can't be false at the same time. So on any row of your truth table, the basic sentence letter values have to be consistent. If you assign it a value in one row, it has to have that same value across the row. Okay, now, the important advice. If you get lucky and this row you're assigning directly turns out to be invalid, you win, you're done. You only need one invalid situation to disprove an argument. In a full truth table, you might have multiple rows that prove it invalid. Any one defeats it. So if you're working an abbreviated truth table, you find an invalid case, you're done. Write down invalid, you did it, just make sure you follow the restriction of 4. You did it consistently. But here's the tricky part. If you do not find an invalid row, you have to make sure you tried all the possibilities. Remember, right? We have to look at all possibilities in a full truth table. In an abbreviated truth table, we need to make sure we did consider all possibilities. Now, this can often be done in a single line, but you have to make sure there were no other possible ways. I'll explain what that means as we go. Again, you must have these in your brain, right? Or have them right next to you, right? We need to rehearse these. So let me annoy you. Let's go through them. I am telling you, it is very important that you say these out loud, right? Your brain works a lot better in memorizing if it has a bunch of different inputs. So, repeat. A negation reverses the truth value of a sentence. An and is only true when both sides are true. An or is only false when both sides are false. A conditional is only false when ordered true then false. And a biconditional is true when both sides are the same. Have those in your head. You will need to know those very well to be good at this abbreviated skill. All right. So let's look at an example that we already saw before. We already did a full truth table of this, so you can always compare them, right? Go look at it if you want. This will be our starting example. What do? We write the argument out on a single line. Then we label our main connectives, right? Notice I found a bigger arrow that I could use. Hopefully that helps. If the sentence is its own premise or its own conclusion, it is the main connective. It is just a sentence, so it is its own main connective. There we go. Now, I want these premises to be true under their main connectives and the conclusion false. Most of the time, that means I will start with my conclusion. If your conclusion is, and now listen to me carefully, easy to make false. Now notice by easy here. By easy, I don't mean there's multiple ways to make it false. I mean there's only one way to make it false, or if things are really complicated, if there's only two ways to make it false, then maybe you'd want to start there. We definitely want to start with our conclusion because it's very easy to make false. Now, notice what I'm going to do. I'm going to label this line as line X, just so we can talk about it, and so we can see that line X has to be a consistent situation that could occur. All right, so very clearly. We want premises true, conclusion false, so there is only one way to make this conclusion false. That's what I mean by making sure you've tried all possibilities. If there are multiple ways to make the conclusion false, then I have to consider the various ways. But in this case, great simple conclusion. What value, now notice how corny this question is, what value must R have to make the conclusion false? Well, R is our conclusion, so obviously R has to be false for us to even have a start. That is our main connective, so I circle it. Good. What does this mean? Key rule. If R is false in a line, it has to be false wherever it appears. This must be a consistent situation. Now, what do? When values give you content to fill in any of your other connectives, do so. Maybe it'll give it away. Maybe you'll have an incredible shortcut, or maybe you fail absolutely right away and you don't have to do extraneous work. So what do we have here? Because I am forced to make R false because it's false in line X anywhere, it has to be consistent. That means I have some content here. If R is false, then of course not R is true. I can use my little trick. Let's see if I can do it well. I can shade that in to get rid of it. You could cross it out, or I would underline the values that are more important, right? Now, we already know the value under this or here. Good. An or is only false when both sides are false, so this or is true. So notice what we've done. In simply assigning false to our conclusion, we already have the necessary value of our first premise. So far, so good. So what do we do now? Now notice. Easiest place to work here would be this premise, because this premise is W by itself. Good? So I know that, now remember, I want my conclusion false, premises true, so I would want W to be true. Okay, so pause there because I want to show you something nerdy. If you look at this premise, right, let's say W isn't here, let's cover that up, let's pretend we don't have that. If we were just looking at this second premise, notice what we would find. This is a conditional. What do we know? A conditional is only false when ordered true then false. We want ours to be true. We're trying to prove this invalid. A conditional is only false when ordered true then false. What do you know? This thing is already true no matter what happens to W. A conditional is only false when ordered true then false, so this can't become false no matter what happens to W. All right, less nerdy, let's go to the obvious. I want true premises and a false conclusion, so what does that mean? I'm going to need W to be true. Is there? Super corny. Are there any other ways to make this premise true? Of course not. It's W by itself. That is the main connective. I circle it. What does that mean? I have to have consistent values, so W has to be true in line X wherever it appears. What does that do to this second premise? A conditional is only false when ordered true then false, so this premise is true, and so I win. What does that mean? I was able to, in a single line, prove this argument invalid. All right, so let's try another example that we've already looked at, right? So this is our, Snarfblatt argument. Good. All right, so look at this one. We write the argument out on a single line. We clearly label, again, I would draw little stars, right, or happy faces or something over these main connectives. These are the values I'm concerned with. So here we have our argument. What is our goal? Our goal is to find a case where the premises are true and the conclusion's false so that we can declare this invalid. We are terrible people. All right, so I'm going to label this first line as line X just so I can refer to it. All right, so let's start in line X. I want my premises true and my conclusion false. In this case, I have a little more complicated conclusion, but it's actually very friendly. What do I mean? Our main connective in our conclusion is a conditional. How many ways are there to make a simple conditional false? Only one. A conditional is only false when ordered true then false, and I want this false, so what do? I will assign S as true, T as false. That is the only way to make this conditional, this conclusion, false. Do you see it? Yeah, that's great. This is a great conclusion to have. It gave me two values necessarily. Are there any other ways to make it false? No. S has to be true. That means what? S has to be true wherever it appears. What does that mean about T? Wherever it appears in this line X, in this world, T has to be false. All right, so let's see what we have. If you're looking at this and you know your truth conditions, you know that we're in danger. Right? If W turns out true, we lose. Good? Look at here. Let's go to the first premise. The left side is true. A conditional is false if it's ordered true then false. We don't want that. We want it to be true. If you're a big nerd, you're already seeing what's going to happen here. Good? I want this premise to be true. If W is false, it's false. So I need W to be true. If W is true, this conditional is true, and I've saved my first premise. But we need consistent situations. If W is true in line X, it has to be true wherever it appears in line X. What does that mean? Damn it. If W is true, then this conditional is false. A conditional is false when it's ordered true then false. So what happens? We lost. Did we try all possible ways? Yes. All we did was force this conclusion false. That was the only way, and that necessitated these other values. So that's as far as we could get. This argument is valid. We lost. We tried to make it invalid. It couldn't be done. We tried our best, and we failed. We tried every possibility, and we couldn't get any farther than this one. All right. Another example before we get to the U exercises. Look here. So what do? Write our argument on a single line. Clearly label our main connectives. These are the values we're worried about. Good. And again, we have a very friendly conclusion. Now notice, a little tiny complication with the negation, but what do? What do we want? We want at least one line. Hopefully we can do it in one. We'll call it line X, with true premises and a false conclusion. we want this conclusion to be false. In order to make the conclusion false, obviously, what do we need S to be? We need S to be true, so the negation is false, right? So please work with me. I would love it if you are talking to me. As you hear me hesitate, fill in the answer. That will show that you really know what's going on. All right. What does that mean about the value of S here? Notice, negative S is false, but the original value S is true. We have to be consistent. Now, if we are really savvy, we would know, right? Sorry for the nerdy tangent, that this conditional is already true. A conditional is only false when ordered true then false, so this one can't be false. But let's say we didn't see that. Look at this premise. This is very friendly. We want conclusions false, but premises true. So we must force B to be false so that negative B, the main connective, is true. Is there any other way to make this conclusion false? No, there isn't, so we don't have to look at possibilities. Is there any other way to make this premise true? No, that's the only way to make it true. There's no other values that would make it true. What does that mean about the value of B? It's false. Let's see how we did. Last premise. A conditional is only false when ordered true then false, so this conditional is true. What happens? We won. We rule. We were able to force this argument, right? We were able to force our truth table, and we got the same thing we did in our full truth table. This will always actually be a line somewhere in a full truth table, but we found it directly. Case is invalid. We win. Argument defeated. All right. One more example. Sorry. Let's go to this example that we already covered as well. Let's see how easy it is as an abbreviated truth table, right? A little more complicated, but notice it's fairly friendly. What do we do before we begin? Fill in our main connective values. Be very careful that you have the main connectives right. Otherwise, you'll be working in all the wrong directions. All right. If you can start with your conclusion, that's always great, right? Conclusion's the most important part of an argument, and obviously we have a great conclusion, very friendly. We want our conclusion false, and there's obviously only one way to make it false, by making M false. Conclusion false, premises true. Now where should we work? Obviously N is a very friendly premise. It is just N by itself. Of course, we must make N true. We want our premises true. We're doing good. But if N is true and M is false, right, we already have a couple of our values filled in. Good? Now, if this gave you some necessary values, then you'd fill them in, right? But right now, still lots of up in the air. So let's see where else we can work. Good? Obviously here. We want this premise to be true. What does that mean? We want this negation to be true. So we must make T false. Is there any other way to make that premise true? No, that's the only way. It's a fairly simple sentence. So far, so good. But now what do we know? We know the value of T. T has to be false. Are there any other ways we could have done this so far? Not at all. We'll probably do this in one row. We have all our values filled in, so we will. What do we know? We look at this OR. An OR is only false when both sides are false. What does that mean? This OR is false. Good? Let's see. I will make this stand out by drawing it in bold. Maybe in your pencil, you can use that technique. You can say this value replaces those. That's a pretty easy way. That's a pretty good technique for being clear. What do I know about this conditional? A conditional is only false when it's ordered true then false. What does that mean? Damn it, we lost. We did our best, right? But that was the only way to make these premises true and this conclusion false. But that led to what? A false premise. We could not make the premises true no matter how hard we tried. So we lost this argument. It's valid. Damn. All right, so let's look at the U exercises starting with number 1. Right away, we write the argument out on a single line. We bold in. Now be very careful. Is the main connective the negation or the conditional? It's the conditional. Good. So we label clearly, draw stars, happy faces, whatever you want above your main connectives. Those are the values we worry about, right? Sorry, mine aren't very bold. It's not super clear. Here we go. We have a fairly complicated set of premises, and the conclusion is complicated as well. let me show you what would happen if you don't see any shortcuts, right? We will call this line X just in case we need multiple lines here. If I'm scared off by this conclusion being complicated, right? It's actually going to turn out fine, but it looks scary. So maybe I look for another place. Maybe I look for a place to start in my premises. I want my premises true, so if there's a very restricted premise that's only true in one way, I would start here. But I don't see anything friendly here. Notice, what would happen if I decided to start here by making this premise true? If I made this premise true, notice, I would have to look at multiple possibilities because a conditional is only false when ordered true then false, but that means it's true in 3 other ways. Good? It is true if both sides are true. It is true if it's ordered false then true. It's true if it's ordered false then false. So I would have to look at 3 lines. I would have to look at this situation, true, true, this situation, false, true, this situation, false, false. And how would that work? I would work line X and see if I was able to make the premises true and the conclusion false. If I do it, if I find an invalid case, then great, I lucked out, I won on my first line and I'm done. But if that doesn't work, I would have to look at the next line and the next line until I showed all possibilities before I could say it's valid. So we want to avoid that, right? So let's look at our conclusion again. Our conclusion is a conditional. A conditional is false when ordered true then false. So what do we need? We need this and to be true and this negation to be false. Well, if at the very least all we do is assign the value of b, that's helpful because there are b's everywhere. So we need this negation to be false. So what value must b have? It must be true to make this negation false. Good. I'll draw that in bold so it stands out. Good. Well, at the very least, that was necessary. Is there any other way to make this negation false, to make this conditional false? No. So let's see what that gives us. If b is true, right, b has to be true wherever it appears in line X. If you are very nerdy, what do you already know about this conditional? It's true. No matter what happens to a, this conditional is true. All right, let's skip the nerdiness. Let's go back to our conclusion. I want this conclusion false. So far, I'm halfway there. But what do I need to make sure it's false? Notice, I need this b to be true. I need this and to be true if I have any hope. Good? How do we make an and true? An and is only true when both sides are true. So this is actually a very friendly conclusion. A has to be true, D has to be true in order to make this and true. That is the only way. Notice, that's really important. That is the only way to make that conclusion false. All of these different possible truth values were necessary. There is no other way to make this conclusion false except with these exact values. So this conclusion is actually a goldmine. It gave us a ton of values that are necessarily fixed. What does that mean? A has to be true wherever it appears in line X. All values of A are true. All values of D have to be true as well. Well, now we have a ton of content filled in. Premise 1 is done. A conditional is only false when ordered true then false. So this is a true case. Great. What do we have here? We have this or already solved. An or is only false when both sides are false. So this or is true. Good. I will write that in bold so it stands out. Now, notice what we've got here. This is pretty nice. This is a conditional. A conditional is only false when ordered true then false. And what do we know? It's already true on the right side. It cannot be false. A conditional is only false when ordered true then false, but it can't happen. We win. This conditional is true no matter what happens around it. And on a quiz, if you're doing this, you would simply show that you know this by labeling this premise and showing that value doesn't matter. No matter what happens over here, whatever value this negation has, it won't change the fact that the right side is true, so the premise is already true. We win immediately. A lot of complication, but we found it, As soon as we assigned these truth values to our conclusion to make it false, all the other values made the premises true. We win. True premises, false conclusion. Argument is defeated. It's invalid. We rule. Good. So now let's look at U exercise number 2. This again looks a little complicated, right? So what do? We label our main connectives. These are the values we care about, right? Oops, forgive me. Sorry, hit a key. We label our main connectives, make sure they stand out. These are the values we're worried about. Remember, if a sentence letter is a premise, then that is your main connective, right? So D is a main connective. It's its own premise. Good. We labeled our main connectives, and now we want to work. We want our premises to be true under their main connectives. We want our conclusion to be false under its main connective. Now, an and is our conclusion. An and as a conclusion stinks, right? There are many ways to make an and false. Remember, an and is only true when both sides are true, but we don't want it true, we want it false, so this would be a huge chore. All the different ways of making it false would give us multiple lines. So, let's see if we can do this in a single line. We can if we see the shortcuts. What is the obvious shortcut? Right there. Look at this. If we need false conclusion and true premises, well then we know what value D must have. D must be true for us to have any hope. Is there any other way to make this premise true? No, it's just D by itself, so of course we know its value. Key restriction. Whatever value you assign must be consistently assigned across the whole world, across that whole situation, in this case, situation X. What does that give you? Now we fill in these values. Let's see if it makes anything clear. Well, it does help this. Notice, right here, negative D is false, so our conclusion is already false. So that's helpful, right? We know that D at least made our conclusion false. An and is only true when both sides are true, so at least our and is already false. So that's clear. And technically, we can fill that in. That is necessary. Good? All right, where are we now? Now, C's value right now doesn't matter. Our and is already false, so we don't have a fixed value of C. It could be true or false, it wouldn't matter. But look at this premise. This is a simple premise, and we want it to be true. So obviously, what value must C have? C must be false, so that negative C, our main connective, is true. That is our premise. Is there any other way to make that premise true? No. So we're still just in line X. There's no other possibilities yet. What do we know? C has to be false wherever it appears. So fill in those values. There is also one in the first premise, and our conclusion is all settled. It's a biconditional. Now remember, our and is already false, so we are just filling in the values that we find, but let's fill it in. A biconditional is true when both sides are the same. Both sides are not the same, so this biconditional is false. Those are the clear values, and still false. Now we have this premise is almost already done, right? So let's fill this in. We want this premise to be true, correct? We want our premises true and our conclusion false. So to make this premise true, we need what? A biconditional is true when both sides are the same, so we need both sides the same, so we must force E to be false. If E is false, that makes our premise true. We are doing great, and now we know the value of E. E is false. So we have all our values. We were able to do this in one line. Let's see what we get. An and is only true when both sides are true, so our and is false. We are now comparing these two values. I will bold them so you can see what we're comparing in terms of our main connective, our conditional. A conditional is only false when ordered true then false. So this conditional is, we did it. Our conditional is true. Our final values are true premises, false conclusion. We win. Argument is invalid. We defeated another argument. That is our goal. Remember. True premises, false conclusion makes the argument invalid. All right, let's keep moving. Example 3 of the U exercises. let's look at this. Uh-oh, this is a beast, right? That is something we don't want to have to deal with. So let's hopefully our conclusion is friendly. Our conclusion is an or. What is the rule for or? An or is only false when both sides are false. Well, that's great then, because what does that tell you? There are already only one case in which this or will be false, so we know the values of H and the value of P already. Are there any other ways to make that conclusion false? No, that's the only way, so we're in good luck. Hopefully, we'll be able to solve this in a single line. So, that should give us a great advantage because H has to be false wherever it appears. Damn it, there are no H's. P has to be false wherever it appears. Damn it, there's only one. And it's bad, right? If this conditional turns out true on the left and false on the right, we lose. So that stinks. So what should we do? We don't want to mess with this. There's a lot of possibilities. Look at this premise. Really easy. We want our premises true, so obviously we'll force D to be false. What does that do? That makes our main connective true, right? That is our main connective. We label it. Uh-oh, did I forget to label my main connectives? I did. Let's go back. Let's pretend I didn't forget that. You jerk. Main connectives labeled, right? Oops, sorry. I was so noisy on my keyboard. All right. Is there any other way to make that premise true? No. So what does that mean? We have the value for D in line X. It has to be false. That's the only one. Damn it. We're still not very far. Oh, look at this premise. That is actually really friendly. We want this premise to be true. We want and to be true. An and is only true when both sides are true. Now we have more values. It is obvious, it is only case, the only way this premise can turn out true is if R and B are true. So now we have some values we can work with. That is the main connective. So far, so good. What does that mean? R is true wherever it appears. Damn it, there's only one. B is true wherever it appears. There's only one. But we are now in the first premise. We have enough values to determine the value of M. We want this premise to turn out true. Good. A conditional is only false when ordered true than false, so we can't let this M be false. We need to make this M true. That saves our premise. Our conditional is true. What does that mean about M? Now we're getting a little farther. Our M is true wherever it appears. Good. What do we know? So let's fill in the values we know. We now know that this negation is true, right? I will cross out this false here to get it out of our way. So negative D is true. What do we have? We need this conditional to be true. How can we make it true? If it is false on the right, we're in danger. If this conditional turns out true, then false, we lose. So we need this left side to be false. What do we have left? Everything here is true, right? Let's see what we can do. All we have left is J, right? What can we do? We need the left side false. Our only hope, let's try it, is to make this, sorry, what do we see here? We already have an and filled in. And is already true. Uh-oh, we're doing bad. Let me knock these out of the way, right? So you can see what we're looking at. Oh no, what happened? We already know that no matter what happens here, look at what we're comparing, right? An or is only false if both sides are false. What do we know? This or is already true. Do you see why? No matter what happens to this and, no matter what values this and has, it doesn't matter because one side of our or is true. What does that mean? Our or is true, our negative D is true, and those are the values that determine this and. What happens? No matter what happens over here, no matter what values we end up with, good? This or is already true, this negative D is already true, so this and is true. Damn it. Right? I'll bold that so you can see what's going on. That is a lot of complicated work, but what happens? The left side of our conditional is true, the right side is false. We lost. That was tricky, but we couldn't do it. In assigning these values, these were the only values possible. These are the only values possible. We had nothing we could do to rescue this or. These values were already true. Nothing we could do. These values forced this premise to be false. We tried all possibilities. That was a tricky case. What did we find? It's valid. We lost. Damn. Very hard case. All right, new exercises number 4. Hopefully this one's not as hard. Good. So we'll start, right? I'll label this line X so we can talk about X. We label our main connectives. Yes, I do remember to do that right away sometimes. Good. Label our main connectives. There they are. Conclusion is E by itself, so it is its own main connective. Now, obviously, the conclusion is really friendly. The conclusion is a single sentence letter, so obviously we'll start there. E has to be false because we need our conclusion false. There's no other value E could possibly have, so our conclusion is a good start. What does that mean? E has to be false wherever it appears. Oh, good. We're on our way. Uh-oh. There are no E's over here, so we don't have much content. So let's see what we've got. Here is a conditional. We want this conditional to be true. Right now, we're in danger of losing it. A conditional is false when ordered true then false. We don't want that. So what are we going to do? We need to force A to be false so that we can save this premise. Let me repeat what I've done. Because E is false in our conclusion and had to be, we're still on one line probably. Right? Because E is false, we had to make A false, otherwise this conditional would have turned out false. We want it true, so we had to avoid the true then false case. We didn't. A has to be false, so A has to be false wherever it appears. All right, there's still a lot going on in premise 1. Let's go to premise 3. Oh, we have the same situation. If D turns out true, we lose this conditional. It will turn out false, so we force D to be false in order to make our conditional, our main connective, true. Good. That is our main connective. We circle it. So far, so good. What do we know about the value of D? We know that D is false. All right. If we can make this or true, we win. We will prove another argument invalid. Let's see. An or is only false when both sides are false. So all we need is one of these to turn out true. All right, let's look at this one. Let's try to make this true. An and is only true if both sides are true. Oh no. Both sides can't be true because the left side's already false. So this and is already false. No matter what happens here, won't change that. An and is only true when both sides are true. So we lost that side. All right. We just need this right side to turn out true, and then this main connective will be true. Let's work on it. All right. An and is only true when both sides are true. Damn it. We can't make both sides true. This and has to be false. So we couldn't rescue this premise. We lost. It is false. We did our best. We tried all possibilities. Make sure. Were there any other ways to make these true with this false conclusion? No. Damn it. We lost again. Example number 4 is valid. Damn it. All right. Let's see if we can do better in 5. Example number 5 in the U exercises. Ooh, this looks like a monster. All right, let's see if we can do better in exercise U. We've got to defeat some of these some of the time, right? Exercise U number 5, let's see. If we, and let me do this. Let me show you what would happen if you don't see shortcuts, right? So let me label 2 lines, and let me show you what would happen if we started here. If we started with our conclusion, let's just look. I know you nerds are telling me don't start there, but let's see what it would do. Good? If we start in our conclusion, we want our conclusion to be false. Well, notice we have a biconditional. Let's label our main connectives, right? Again, Jeff almost forgot that step. You do it too. I'm not the only one that forgets this. So label those clearly. Those are the values we're concerned with. Our main connective for our conclusion is a biconditional. We want our conclusion false. What does that mean? A biconditional is true when both sides are the same, so we don't want both sides the same. But notice, there are two different ways that we can make this false. Look at it. Those are two ways where the conclusion is not the same. But at least there are only two ways to make it false. It could have been much worse, right? So there are two possibilities. What does that mean? There are two possible ways to make our conclusion false, so we cannot stop. Now notice, please note, if we started working line X and it showed an invalid case, then we got lucky and we're done. We only need one invalid case. But if it doesn't show an invalid case, we would have to look at line Y as well because there's multiple possibilities. So let's try that strategy. Good? So let's work line X. What do we know about line X? We know that B is true wherever it appears in line X. And we know that C is false wherever it appears in line X. Good? So let's see if this gives us a case we can work with. Let's look at this first premise. Good? This conditional is false. Got it? A conditional is false when ordered true then false, so we lose. Uh-oh, what just happened? Do you see what already happened? An and is only true when both sides are true, so we already lost this one. What does that mean? We couldn't prove it invalid in X, so we have to look at line Y. All right, so line Y. We lost line X. It already looks valid so far. Does that mean the argument's valid? No, there are still other possibilities of proving it invalid. We can't declare it valid yet. Let's see. In line Y, so let's look on line Y. In line Y, B is false wherever it appears, and C is true wherever it appears. B is false, C is true, B is false. Got it? So we have those values assigned. Let's go to our first premise, right? Let's see. In this case, a conditional is only false when ordered true then false, so this conditional is true. Good, we're doing well so far. So let's look at the left side. Left side says, right, we want this and to be true. A conditional is false when ordered true then false. Well, notice, we have an and. An and is only true when both sides are true. One side is true, we need this side true as well. So what does that mean? If A turns out true, this conditional turns out false, but we want it true, so A has to be false so that this conditional is true. If the conditional is true, both sides of our and are true. That's the only way to make an and true. That is our main connective. We circle it. Phew. So far, so good. We have a chance. What does that mean? That means that A has to be false wherever it appears. Good? Do we have any A's? There we have one right there. Damn. An and is only true when both sides are true. So what happened? We lost. See it? An and is only true when both sides are true. We had to make A false here, but that means one side of our and is false. We cannot make this and true, so we lost. No matter what we did, when we looked at both of our possibilities, we could not make our premises true, so this case is valid. All right, but let's go back. Let's look at another way we could have solved this, because some of you, very smart folk, are saying, Jeff, why didn't you start here? You might be able to do it in one line. All right, so let's back all of that off, right? Let's go all the way back to the beginning. Good. Erase, 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 erase. Good. All right, so let's say you see a shortcut, right? We're starting over U exercises number 5, and we're going to do it in a different way. Let's see if we can do it in a shorter way. It'll be trickier, but let's see what we can do. Let's say we don't want to use 2 lines, and we see right here. This premise is nice because there's only one way to make it true. Yeah, let's work. An and is only true when both sides are true, so we know the values of both A and E. Oh, sorry. That is the main connective. We circle it, right? So we're off. What do we know? That means that wherever A appears, it has to be true. That's the only one. Wherever E appears, it has to be true. That's the only one. But notice, if you're good at this, we can do this in one line. Because what? If we look at our first premise, we want this and to be true. Good. So we need both sides true. An and is only true when both sides are true. Well, the only way to keep this conditional true is to prevent this b from being false. So we need this b to be true. That makes this conditional true. I'll bold it so it stands out. Oops, dummy. Sorry. I will bold it, right, so that it is there. Good. So far, so good. But now we know the value of b. In order to have any chance of making this and true, to make the conditional true, we already had a true. We needed b to be true. So b is true wherever it appears. That gives us a lot of values, including a value in our conclusion. So what do we know? We know necessarily in this version of line X that b has to be true. What does that mean for c? Look at it. This means that c, because we want our conclusion false, has to be false. A biconditional is true and both sides are the same, so we need both sides different. So c has to be false. What does that mean? C has to be false wherever it appears. Let's see what happened. First premise, C has to be false. No other way to make that conclusion false. If C is false, what happens to our conditional here? It makes our conditional in premise 1 false. What does that mean? We lost already. If you saw that shortcut, you did this in one line. It took some more rigorous work, but if we started here, that necessitated these values for B and C, and that made our conclusion false, but our premise also false. What did we do? We tried our best in this step as well, and of course we're going to get the same answer if we do it right. We lost. We couldn't make the premises true with that false conclusion, and so this argument is valid. We lost. All right, so let's look at U6. Oh, this one's a beast. This terrible thing. We wrote our argument out on a single line, and now we're labeling our main connectives, right? So go through. You will draw stars over yours, happy faces, make them stand out. We are looking at this thing, right? And look carefully. I'll sit here and stare at it with you. Do I see any clear shortcuts? No. This thing's an animal. I hate this. Look at this jerk. Right? There are no clear shortcuts. I don't see any values that can be assigned really easily, so I'm going to have to look at multiple rows, right? Sometimes you just have to do this, right? What do I see? I don't see any shortcut, so start with your conclusion. It's at least a little less complicated than some of these other possibilities. So we'll start with our conclusion. What value do we want our conclusion to have? We want it to be false. Good? It is an and. An and is only true when both sides are true, so what does that mean? There's 3 different ways to make this false. Watch how I'll work. Now notice, I'm going to look at the values that determine the value of and, so I can be more careful. I know that and will turn out false if negative x is true and z is false. It will also turn out false if negative x is false and z is true. It'll also turn out false if negative x is false and z is false. Notice what I've done. Those are the 3 ways that would make this false. Good? And so notice I'm really careful. What are the actual values of x? False, true, and true. So at the very least, I know I'm going to need, and this is so to make it easy to refer to, I'm going to at the very least need 3 lines. So we'll label them x, y, and z. What does this mean? I have 3 ways that I can make my conclusion false. There are the main connectives for each line. This is how this works. Because there are multiple possibilities, I might have to look at multiple possibilities. I will work line X and see if it gives me an invalid case. If it does, I win and I'm done. If it doesn't, I'll have to work line Y and see if it gives me an invalid case. If it does, I'm done. But if it doesn't, I have to work line Y and make sure I look at all possibilities. If it gets me an invalid case, good. Otherwise, it's only after looking at all possibilities that I could say this is valid. All right, so let's work line X. In line X, what are my actual values, right? In line X, X is false, wherever it appears. And Z is false, wherever it appears. right? So let's work this line. Let's fill in the values we know, right? So if x is false, what does that mean? Not x is true. I will bold that so you can clearly see that that's the value. Now, what does this mean for this premise? An or is only false if both sides are false, so that's good. So far, this or is true. Let's see what else we can find. Good? Let's work here. I want the premise, this third premise, see where I'm working right here. I want this premise to be true. In order to make a biconditional true, I need both sides the same. Now notice, if you didn't notice, sorry, let me go back. The value of W doesn't matter, right? I can even make a little note for Jeff. Jeff, I know this value doesn't matter because an or is true as long as one side is true. So now let's go back. Sorry, I should have been more careful. I need this biconditional to be true. A biconditional is true when both sides are the same. So one side is false, so I need this side to be false as well. Notice, this is a lot of work in your head. I need both sides the same, so left side's false, I need the right side false. What does that mean? I can't have both of these the same. I must have W to be true, so my biconditional is false. And so now, look at the values I'm comparing. Both sides are the same now, so my biconditional is true. I have saved this premise as well. Good. What does that mean? I now know the value of W. W is true wherever it appears. So what does that give you? If W is true, that means not W is false. What does that mean? An and is only true when both sides are true. So this and is false. What did that do? This is awful. This made this conditional false. I lost line X. Do you see the work? I had to make W true to make this biconditional false to preserve the main connective here, but when I made this W true, I clearly lost my and. Some of you nerds would know the and was already lost because one side was false. Nice. That sucks. So I have to look at line Y. What do I know in line Y? Look carefully. X is true and Z is true. So wherever X appears, it's true. Wherever Z appears, it's true. Let's see what we've got here. Let's go to premise 1 again. If X is true, then negative X is false. I'll bold that so you can see what I'm comparing. What does that mean? I'm in danger of losing this or. So what value must W have? Because I need at least one side to be true, W has to be true to preserve the truth of this or. Good. That is my main connective. I circle it. So far, so good. Let's see. Now I know the value of W. W is true wherever it appears. Actually, I have all my values filled in now. So let's see what this gives me here. Here, this makes this negation false. So look what I'm comparing. I'm solving for and is only true when both sides are true. What does that mean? This and is false. Let me bold the values I'm comparing for my conditional. My conditional, false again. I lost. Again, couldn't get past the second premise. I can't make, so line Y failed me. So I have to look at line Z. Let's see line Z. Line Z says, be careful, X is true and Z is false. So X is true wherever it appears, Z is false wherever it appears. X is true, Z is false. First premise, what do we got? Let's fill it in. If X is true, then not X is false. I will bold that value so you can see it. What does that mean? We're in danger of losing our or. We need at least one side true. You know what's happening now. So what is it? So W is true. We saved the first premise so far. Good. So first premise is true. Those are the values. What does that mean? I now know my value for W. W is true all the way across in line Z. It has to be to save the first premise. So let's see what we've got. That makes this not W. I'm working right here. False. What does that mean? We again lost our and. I will bold the values we have. It is false everywhere. Sorry, False on the right, true on the left. What does that mean? We couldn't get past this premise. Every case we tried, and we had to try all three because we didn't find an invalid case. What did we find? We lost. The argument is valid. We could not find a situation with true premises and a false conclusion, and we tried and tried. All right, so I would stop right there if I'm a normal person. If I'm normal, I stop there because these last two examples are really hard. Good? They are very difficult. They can show you some really advanced techniques if you want, so follow, but don't worry if you can't get ahead of me on these ones. You can stop here. You have everything you need, but if you are a big nerd, I warned you, right? You should have stopped. All right. All right, I warned you. These are bonus examples. Okay, I warned you. So let's look at bonus example number 1, right? Really tricky. We label our main connectives like we always do. There we go. Oh, damn it, Jeff. We label our main connectives like we do. There we are. Filled in. Good. In case you have easily distracted, let me get that one out of the way. Good. All right, so let's work like this. So now we're looking to see if we can find any shortcuts, right? This all looks very complicated, right? So notice, this is a bonus problem, right? I'm going to find the shortcut. Notice, this has how many sentence letters? 4. I don't want to do a 16-line truth table. I could, right? But I don't want to. So let me search and search for a shortcut. Now, one possible shortcut would be to start here because I can do this in 2 lines. So that looks good. But I'm going to be even more careful, even more sneaky. I'm going to start here. Notice, I do not want to fill in the values of this conclusion because that can get complex, right? But I do at least know to make this conditional false, I know that B has to be false. I do not know the values of A and C from my conclusion, but I will start there. Now, please notice, if you take a shortcut, make sure, if you take a radical shortcut like this, make sure to label it. Make sure to, what I would do is I would write a little number 1 so I know where I started. So that when Jeff is grading my work, he knows that I saw the shortcut. The shortcut was starting with B by itself. All right, so let's work. I know that B has to be false if there's any chance of making this conditional false. I don't know these values, but I at the very least know the value of B. Right? So B is false wherever it appears. Good? Only one case, but that's enough. Because look, if I look at the second premise, what do I find? Second premise, I know that I want it to be true, but I'm in danger of losing that conditional. If this D is true, I lose that conditional because it will be true then false, so I have to force D to be false. Good. I have reserved the truth of this premise by assigning D false. Well, that's good because that gives me some more values I can work with. D has to be false wherever it appears. Notice, that now fixes this third premise. I need this biconditional true, so I need both sides the same. So I know that C has to be false, so that gives me another value. The biconditional is true because both sides are the same, and now I have the value for C. Oh, this is good so far. C has to be false, right? Let's see what this gives us, right? We need, so now we can solve our conclusion. We need our conclusion false. So what does that mean? We need this OR to turn out true. An OR is false if both sides are false, so we need one side true. What does that mean? We must make A false so that not A is true, so that we save this OR. Notice, I'll bold it so you can see what's happened, right? Those are my values. I needed A to be false, so negative A is true to keep this OR true. That's the only way to keep this OR false after assigning these values. Good. What does that mean? I now know the essential value of A. So far, only one possibility if I started with B. So now I know A is false in this line. So everything is solved. Let's see what I've got. Negative D is true. What does that mean? This OR is true. I'll bold it so you see. If you're a nerd, you already know we did it. But let's solve this. A conditional is only false if ordered true then false. So this is also true. What do we know? An OR is only false if both sides are false. So OR is true. We won. Complicated case. We solved it in one line. It's invalid. We rule. Bonus case number 2. Let's look at this. We label our main connectives, as always. Oops, sorry. Get my cursor out of the way. Main connectives, here they are. Those are the values we want. We want this invalid. Fill in our main connectives. We want true premises and a false conclusion. So far, this is another beast. I hate this thing. Look at this. I don't see any case at first glance where I don't have to do at least 3 lines. Except, right, now I'll let you stare at this a little while. I'm super proud if you see the trick. Nobody saw it. There's no way you saw the trick. But where's the trick? Here. Here it is. What do you see? If I want this and true, there's a lot going on here, right? Good. There's many ways to make that true. But there's only one way to make this true. I know that A has to be false so that this negation turns out true, so I have any chance of making this and true. I don't know if it's true yet, right? That will depend on the values of M and P, but I do know that O has to be false, so I have any chance of saving this and. What does that do? That means O is false wherever it appears. What does that mean? Look at what it does for my conclusion. The conclusion is the most important, so work on it as quickly as you can get to it. What do I know? One side of my and is true. I don't want that. I want the and to be false. So now I also know the value of P. I must make P true so that not P is false, so that my conclusion, my and in my conclusion is false. What does that mean? I now know the value of P as well. P has to be true, look carefully, wherever it appears. Good. So now what should I solve? Let's go here, right? I have values on one side. I am trying to preserve the truth of my premises. I want this invalid. I want true premises. What does that mean? L has to be true. That's the only way to save this OR. So far, so good. What does that mean? L is true wherever it appears. What do I have? Let's look at this conditional. A conditional is false if ordered true then false. I want it to be true, so notice I can't let the right side turn false. So what does that mean? I must make M true. If M is true, then this conditional is true, and that gives me a true main connective. A conditional is only false if ordered true then false. I avoided the false case. My premise is true. What does that mean? I now know the value of M. Look at it. These values were all necessary if I started here. And so I would label this, Jeff, I started right here, and that gave me all my other values. M has to be true. What does that give me? This conditional is now true. A conditional is only false when ordered true then false. And I won. I was able to solve this very complicated case in just one line because I saw the shortcut starting with O. Again, make sure if you see an incredible shortcut, you show me where you started, and then you can follow a shortcut. I win. Argument is invalid. So excited I couldn't spell it. I win. Thank you very much for following. You did good.